Good morning, good afternoon, good evening, everyone. I hope all of you are doing well and doing great. So, guys, my name is Deepak Sharma, and I have 15 plus years of experience in this field. So, this is going to be the agenda for today. We are going to talk about, what is basically, CompTIA, what is CompTIA, Security Plus exam. Often people get confused that, what is it? So, I hope it will really help you in clearing the doubts that you have, and we will going to talk about why should you take this this certification, what is the benefit of it, why it is like how it can be helpful, and what is the eligibility, because it's not like that anyone can take this certification. So there is a certain eligibility criteria. We are going to talk about that, so it's going to clear your doubt. And we are going to talk about what are the different skills that you acquire, basically which are required to just get this certification, and what are the focus areas and the examination questions, like what is the pattern, how many questions you gave in the examination, and all those kind of stuff we're going to talk about, and the duration of examination. So let's get started. So let's talk about what is CompTIA. A term which is oftenly confusing to others. People think that, oh, CompTIA is a cryptography, CompTIA is encryption, CompTIA is a cloud platform. What it is? So basically CompTIA, if you talk about the full form of CompTIA, it stands for Computing Technology Industry Association. That's a full form of CompTIA. So basically, this is just a non-profit, association which is based in America. So this organization issues, vendor neutral professional certification in more than 120 nations across the globe for the IT industry. That's why it has, much more precedence. Now let's talk about, what is, CompTIA Security Plus exam. What that is. So you got it, what CompTIA is, but what is the CompTIA Security Plus exam? So CompTIA Security Plus exam basically is a globally acknowledged certification exam. It's not like that it's going to be applicable only in America or India or UK or different countries. So it's a globally acknowledged certification exam which confirms that the standard skills that you need in order to perform important tasks dealing with security and to pursue a career in the IT security professional. So like for the Microsoft, provides you, like CCNA, CASSP. Likewise, this is basically, from CompTIA Security Plus exam. So, wherein if you put, if you're basically, certified, if you're going to put it in the resume, you're going to get more precedence for the jobs. Plus, you're going to learn about all the, different facts. Now let's talk about, why you should take, CompTIA Security Plus, certification. Like why it's important, for you to take, and what is the benefit of it. So these are the benefits of CompTIA Security Plus certification. Again, it's an industry standard, like you said, that this is not like kind of a standard which is basically, acknowledged by, within a local country. It's basically global, recognized certification. It's basically a vendor neutral, which means that, it's not like that. Okay, it is associated with the Microsoft. It's associated with your, one of the, let's say, only cryptography world, only on identity access management. It's vendor neutral, which means that it covers all the basics, and I would say all the major technologies which are required for, your security, organization. And again, we are going to dive in more detail, which will give you more, clarity. This is, again, increased salary. So if you have basically the certification, it will help you in getting a more growth in your organization. If you are trying to build a career, if you basically have this, certification in your resume, it's going to, give you more weightage while, applying for the jobs, and while, changing the job, or within the company itself, you want to go for IJP. IJP stands for internal job posting, wherein what happens is, like, for example, you're working into, let's say, just one of the monitoring thing into the security organization like SIM or SOC. It basically help you, in switching the jobs as well, wherein you can, change your role. You can just get a more stable role where your salary is going to be increased. And this has basically worked across the sectors. So it's not like that this is only applicable for IT industry. It's only applicable for, banking industry. So wherever you have digital stuff, it's going to be helpful for, because wherever you have digital world today, which is almost everywhere, you require computers. If you require computers, you are going to have your data digitally transformed, or I would say communicating from one place to another. So it can be between two computers, to you know uh, computers within the same network, different network, in a two net systems in a same city or a different city or all over the globe, basically, which basically gives you more flexibility in terms of switching the organization, switching the domains as well. For example, right now I'm protecting the security for a bank. I know about their all in and out, like they are using let's say the PKI world. What that is, we are going to dive in more detail a bit later on. So if I'm going to switch the domains as well, my core area is going to be same, which gives you basically give me a diversification wherein I can go to different domains as well, but my role is going to be, same. So in other words, my job security is there. And in demand skills, because this is one of the highest thing in basically, in demand right now. Now let's talk about, what is the eligibility for this, and this is basically, suitable for, for what all people. Because again, like you said, there are, so many confusions behind it. People are not so sure that, this is for them or not, or it's going to help, to them or not. So I hope it will give you, more clarity. So basically, eligibility for this is, you have to have at least 2 years of experience in the same field. So basically, so like the same thing I have written over here. So you can be a system admin, you can be a network admin, security admin, junior IT auditor, security specialist, consultant, engineer. So, but you have, basically, a person who should have basically 2 years of experience in the IT administration, so that your basics are clear about it. So that's the basic thing. It's not like that. Sometimes I have heard from so many people, what they think is, they have heard, oh, they require 10 years of experience, 5 years experience. Not required. You should have, if you have basically 2 years of experience or some equivalent training, which is mentioned, that's more than enough. So it's not like that you require 5 years, 10 years of experience, because the majority of the time, I have seen majority of the time, people think the same way. Oh, I require like 5 years of experience, 10 years of experience. Like for CISSP, I require a couple of years. Not like that. Okay. Now coming to the other part, what are the different skills that you acquire? So you are going to learn a lot of things. Basically, you are going to learn the cryptography standards, different security technologies. Nowadays, in every company, it's getting important that they should have dedicated cybersecurity team. The reason being is, if you have heard a lot, after this COVID pandemic, when everything went remote, so many organizations got compromised. Like Cognizant, they got impacted by Maze ransomware, wherein their entire data got encrypted by basically an encryption key, and the hacker demanded the money for that. Your Zoom software, it got basically also compromised. So that's the reason, the almost many companies are making the standards that anyone in the organization who is using some sort of cryptography, or basically, or any kind of technologies, like you're developing any software, or you are basically doing any kind of stuff which requires some kind of connectivity to the internet, you have to follow some standards. So there is there's again one of the term wherein the people get oftenly confused: the policy and the standard. People think that, oh, policy and standard are same. That's not true. Policy basically means that a policy that you're going to set up for your own organization. This is not going to be a policy for all the different organizations. One of the example is, I'm going to say that I want to issue a digital certificate, and in my organization I have made the rule that anyone who want to get a digital certificate, their key size should be at least RSA 1024. Okay, that's not the policy, because every company can have its own policy. The second company can say that, oh, the minimum key size should be RSA 2048. Third company can say that minimum key size can be, RSA 512. That's a policy. It can be changed from company to company. Other example is, if you are not from this, cryptography world, you will get a hard time to understand this. Let me make it more simple. Let's say one company have made a policy that in that company the standard password policy is 12 characters, that you should have 12 alphanumeric characters. So if the characters are less than 12, or they are numbers or alphabets, it will not allow you to change your password. The second company has a policy to have the policy of having 8 alphanumeric characters. If you don't know what alphanumeric numeric is, it means that alphabets and numbers. Okay, and then third company is saying that, okay, 8 alphanumeric characters and special characters are allowed in the passwords, like at, dollar, any kind of special characters are allowed on that. So this is not a global policy. This is not a something which is globally accepted by this world. That's just a policy which is, to a specific organization, where that they made for them only. Now coming to the standards are basically which are globally renowned standards, because we have to have some kind of standard that has to be adopted by all the organizations. So like as per GDPR guidelines, like I want to get some certification, I want my organization to be ISO certified. So there has to be some standards that everyone has to follow. Like the standard says that for educate security, the key size should be at least 2048, not 1024. It can be 204, it can be more than that, but at least it has to be 2048. And I'm going to show you couple of critical things today as well. So that's basically the standard says. So if you are having a key less than 204, it means that there can be certain security risk which can be there, and if you're using a weaker key size, your data can be compromised, it can be used by the hackers and all this kind of stuff. So basically it's a well-known thing, or I would say a kind of a baseline which is sent, which is set by the global providers, which everyone have to follow. If you want to pass some certifications for your organization, if you want to get into kind of any kind of compliance checks, which is again one of the major requirement in service-based companies. If they want to get a project, certain companies have a demand, oh, this is sensitive data, so the company basically should have this certification. Or let's say it's a healthcare company, they should have HIPAA certification. So that's basically the standard. So the skills that you're going to acquire in this case is, you're going to learn about security standards and the security tools and different products. You are going to learn about security technologies, the different cryptography standards. You're going to learn about installing and configuring the network and host based security technologies. We are going to learn about wireless and remote access security and why it is required, why it is enforced. You're going to identify the different strategies, and you're going to get the knowledge of the IT security principles of different organization. So you are going to get all this kind of skill if you're going to acquire this. Okay, now let's move on and talk about what are the focus areas. Okay, so, what are the different areas that we're going to focus on? So, I mean, we are saying that, okay, CompTIA, is basically a well-renowned certification. You have to basically pass the exam of it. You have learned about, why you should take this certification. What is the eligibility for it? You got all those, things. Even you even learned about that. What are the different skills that you're going to acquire? Now, the question here is, what is the focus area? Which means that what are different things that you're going to learn. The probable security threats, attacks, and vulnerabilities. What are the different threats that you can have? What are the different attacks which can happen? What are the different vulnerabilities which can happen? So you're going to learn about each and everything. So because like we talked about the maze ransomwares, so all this kind of things you're going to learn about it, which will make you cyber safe as well. And then you're going to talk learn about IAM, which is your identity access management. So identity access management is again one of the term which is basically people get often confused. IAM, or you say identity access management, it means one and the same thing. So identity access management means that how you are going to provide, the security within the organization. Like this, every company, almost every company have basically IAM team, wherein you are going to manage the core security of the organizations. Like in the organizations, you have a policy wherein you cannot plug in the pen drive, or maybe in certain companies you have a policy wherein you should not have access to install the softwares. All these kind of security things are basically managed by IAM team, which is identity access management. They manage how your active directory is going to be. I mean, you are going to have the on-prem active directory, or you are going to be on the cloud. All these kind of things are basically managed by the identity access management. So these are going to be the focus areas. You're going to learn about the different technologies and tools associated with that, and you're going to learn about the risk management. Basically, what is the risk which basically lies here. When I say risk, how it can be risk. Risky thing can be your for example, uh, you know this is again one of the common example I'm going to tell you. Every company, I would say, will need some database, right? So it can be the client database. Even if, let's say, I'm a services company, I'm going to have different clients for that, right? So different clients information, I have to store it. And let's say it's one of the client that I'm dealing with, it's basically in the UK. And as per the GDPR guidelines, global data protection regulation, I have to basically secure their components. I inform them that, again, I had the certification, I have everything, and I'm going to take care of it. But I, maybe missed to implement the proper security control on their data. So if their data is compromised, then in that case, it's going to, spoil my name and fame of my organization. I have to, pay the fine to the government, as well as the GDPR guidelines. They are going to impose the fine on me, and as well as I have to pay the fine to the customer as well. So you're going to lose the business, you're going to lose the brand and reputation. So what kind of risk that you can have, and how you can associate with the risk. So basically for that, you should have basically, kind of a proper security controls implemented. And for example, my database application, if I have, it should be properly protected with the key. So all this kind of things you are going to learn and understand, and the architecture and design of all the components. And then comes the most important part, your cryptography and the PKI. So which is basically the building block foundation, I would say. Cryptography basically is a Greek word which is a concatenation of two words, crypt and graphy. Crypt means secret, graphy means writing, and PKI means public key infrastructure. Let me just give you a little bit overview right now, and I'm after this, I will go in more detail. So whenever you are sending some data to someone, like for example, I'm talking in English, you can understand English. If you want to talk to me, you're going to talk in English language only. So if we are just talking with each other, and let's say we are using a communication channel in between us, which is not so secure. So someone can easily eavesdrop our conversation, and they can listen what exactly we are talking. Or maybe I'm telling you, hey, my bank account name is ABC Bank, my bank account number is 1234556, my password is hash $123. So maybe that person can listen to the conversation, and he can try to take the money from my bank. So it basically focuses on the CIA traits, confidentiality, integrity, availability. Confidentiality means that wherein if you are sending the data from one place to another, that data remain confidential. So apart from sender and the receiver, which are the relying parties, no one else should be able to understand that data. That's your confidentiality. Integrity means that if you are sending the data to someone else, for example, I'm sending the data to you that, hey, XYZ, transfer $1,000 from my A account to B account. Someone tampered the data. So Mr. Hacker was able to read my message in between, and he was able to change the data. And what he did, he changed the data that transfer $1 million from A's account to H account. He changed the account number. So he basically changed even the data as well. Now this message is going to be received by you. You will not be able to identify that this is coming from me or not, because you will have my email address, and you will think that, oh, it's coming from me only, so you're going to transfer $1 million. So it can be one of the biggest threat. It can be a nightmare, right, where the entire money is gone. So how you can protect yourself with that, wherein cryptography helps you with that. So you should not have a lack of integrity, wherein if someone has tampered the data, you should be able to recognize that, oh, this data was tamper during the transit. So basically that has a cryptography thing. The PKI means, public key infrastructure. So which basically it basically based on the concept of asymmetric cryptography, but symmetric cryptography also plays a vital role. Asymmetric key means two keys, for providing the security: a public key and a private key. Public key, as the name suggests, it's going to be public. Everyone can see that. And the private key basically is going to be the key that you have to, safeguard, that you have to keep secure. For that, now you have a lot of, secure areas. You have basically HSMs. You have on-premise HSMs. You can have, key vault things where various companies are providing, like Azure are providing, Amazon is providing, Google is providing. You can just take it from them, and you can just store your sensitive components over there on the cloud. So in the case of asymmetric cryptography, this is not something which came out of the blue. So we started this PKI world with cryptography, where we started with a single key. So if I had to send a data to someone, I'm going to encrypt that data with the key, and the other person is going to decrypt the data with the same key. In other words, just to make it simple, I have to send some data to you. I locked that data into a box with a single key. Okay. Just think like it's a lock which has two keys. One key is with me and one key is with you. Now you're going to receive that box. Already have a key. You have to basically open the box with that key. Now the real challenge in this case lies is how to share the key in between. That's your symmetric key cryptography, which means using a same key for encryption and decryption. In the case of asymmetric key cryptography, you basically have two keys, a public and a private. You're going to encrypt the data with the public key and decrypt the data with the private key. If I have to send the data to you, then I'm going to encrypt the data with your public key, and you're going to decrypt the data with your own private key. So these two, keys are mathematically correlated. It's not like that. You can use someone else public key, you can use someone else, private key with that. Okay. So let's talk about now, before we dive in more detail, let's talk about the exam questions, basically the pattern, the kind of a pattern which is, being followed in the exams. So let's talk about that. So in your exams, you're going to have 90 MCQ questions. So where you are going to have 90 questions basically that you have basically complete in 90 minutes. You're going to have some drag and drop activities. You're going to have performance based items. So you have 90 questions which are going to be MCQs, drag and drop activities, performance based items, and then you're going to have an optional survey. So duration is going to be 90 minutes, that you have to complete this in 90 minutes. So if it's basically completed, 90 minutes are completed, you're not going to get enough time. So the exam is going to be stopped at then and there only. Okay. So that was it about our CompTIA stuff. So let's get going. Let's basically talk about about some of the key areas, the key important things which is related to cryptography, PKI, and other components. So let's get it going now. Let me just minimize this. So basically, like I said, in the case of cryptography, it's basically concatenation of two words, which is your crypt and graphy. Your crypt means secret, and your graphy means writing. So basically, what cryptography rule says is you have to convert your plain text data to ciphertext. Like let's say I have a plain text data. I want to send some data to you. That like I said, one of the use case, transfer, let's say $1,000 to my another account, and someone have eavesdrop the data. Like first of all, how someone can eavesdrop your data? It can only happen if that person can understand your data, right? So if I'm going to change the data in such a way that no one will be able to understand it, so it's going to provide you more security, right? So for example, I'm sending you #123 blah blah blah. If no one can understand that data, then my data will not be compromised. So it sounds like something, for some of you who never worked on this, you will see it should be unrealistic. How it can be possible? How it can happen that you can have a data which no one can understand and you can understand? It doesn't sound practical, right? But that is practical. I'm going to show you in a moment. So this world basically has all the, concept of keys, that you're going to, learn in a bit right now. So wherein with the help of a key, you just perform encryption, decryption, and each and everything. So like I said, cryptography means to convert the data into another form. So wherein you have a plain text data, like uh, oh, let me make it more simple. You have a data that you can read, in a readable form. Let's say, hi, I am test and transfer $1,000. Okay, you made it in thousand, not 10,000. You made it in unreadable form, and it's converted into this, like this. It seems unrealistic, but that's true. So basically this readable form is known as plain text, and this unreadable form is known as ciphertext. So whenever you are going to, see, a term plain text in this cryptography world, which basically means that, data that's something that you can read and something that you can understand. And if you basically see some ciphertext basically means that, a data that you cannot, read and you cannot understand. So it basically requires some kind of, I would say, a security key with the help of which you can perform encryption and decryption. Again, it's a very vast topic. So in the case of, cryptography, you have basically two major types. One is a symmetric key cryptography, and second is your asymmetric key cryptography. In the case of symmetric cryptography, you have basically one key, a public and a one key, no public and a private. With the help of a single key, you are going to perform an encryption and decryption. So if I have to encrypt this plain text data, for encryption, I'm going to require this plain text and a key. And for decryption, let's say if I have to decrypt the data, for decryption, I'm going to provide, the ciphertext, because this plain text plus key is going to produce the ciphertext, something like this. Now for decryption, I'm going to add this ciphertext to the same key with the help of which I perform encryption, and it's going to produce the plain text back. I'm going to show you this practical. It will give you more clarity. For asymmetric cryptography, you basically have two keys, a public and a private. So in this case also, in the case of asymmetric, same concept will remain, plain text plus key. But in this case, your key is going to be a public key. In the case of decryption, you're going to have a ciphertext, which is this one, plus the private key. Now, on the digital world, wherever you have the secure things involved, you are going to see this asymmetric key. For example, if I show you the Edureka side, so if you see basically the key that we are using RSA2048. This is our public key, the key that we actually use. Let's say it's using SSL, right, where you have digital certificate. They are also using RSA2048. If I go here, this site, you will see they are using ECC, which is again an asymmetric key. This is one of the type of asymmetric key. So ECC, so asymmetric keys can be of different types. It can be ECC, RSA. They all are asymmetric key. So wherein you are going to have two keys. Now there are various APIs available with the help of which you can generate the key. Like this is one of those. I want to generate, let's say RSA2048 bit key. So it's going to generate two keys, a public and a private. With the help of public, I can perform encryption. With the help of private, it's going to perform decryption. So let's say my plain text data is, hi, I am test, and this is my public key. It's going to encrypt the data, and this is my ciphertext. Like in this case, particularly, you have seen the example was this, something, weird format that you cannot understand, right? Now see how my hi, I am test data got converted into this ciphertext. Now I want to retrieve my original data back, so I'm going to pass my data, which is the ciphertext, which is this guy here that you can see in the screenshot. Now this ciphertext is going to be decrypted with the private key, which is this guy. So if I'm going to paste it here, and if I click on decrypt, here we go. You get the same data, which is hi, I'm test. So you can have, like, this is another tool with the help of which you can just generate as many keys you want. Let's say I want to generate 2048, or let's say I want to generate 4096, which will take a little more time. It will generate the key and it will show you the time, like how much time it basically has generated the key. So likewise, on different sites, you can see, everywhere you go to any of a banking website right now in this session as well, click on details, you will see public key everywhere. you know it can be different asymmetric key, but you are going to see public key everywhere on any site you go. So this is again using Java, so you can have different even programming language, different technologies that you can use. Even let me show you one of the the custom built program that I have written on my virtual machine. So here basically I have created an asymmetric. So I hope you got a fair understanding about asymmetric key, wherein you have two key involved that you have basically have seen here, public and a private. Let me show you an example of symmetric key, which is this guy where you have one key. Okay. So I have basically written a code for AES. AES basically is symmetrical algorithm which use one key. Let's say I want to encrypt the data. My message is hi, I am test. Or let's say testing. Okay, it's going to ask for the password. I'm going to show you the password in a clear text format, which will act like a key. And this is my ciphertext, which is basically produced. You know, now I can decrypt this data. For decryption, what I will need? The ciphertext that I have, shared here. This guy, ciphertext plus key, right? The theoretical that I have shown you. Now, if I'm going to paste this ciphertext here from the top and I hit enter, now it's going to ask the password. Now, what I need for the decryption, a ciphertext, and what I said is the same key. In my case, my key was this Deepak. So I'm going to put the same data here. Here we go. You got the same plain text back. So same thing I have shown you theoretically here, where you get ciphertext plus key is going to produce a plain text. It has produced the same plain text back. Isn't it cool? So that's the way the encryption works, with symmetric, asymmetric and all. Okay, guys. So I hope you got a very fair understanding about each and every component. And this is just, I would say the start of this word. There are so many things and so many cool things you can do, with this. Once you basically, learn all these technologies, it's basically helpful for your personal and professional life. Wherein you learn about so many, things, so many, I would say, the core areas which basically help you in getting a fair understanding about all the core components. So this is just a beginning of it. So guys, if you want to learn more, want to go in more detail, dive in more detail, then enroll for the course and get everything covered. And like you said, there are so many areas, like this is just symmetric, asymmetric, this is just a part of cryptography. There are so many things that like we have different algorithms, like on the websites majorly you have seen, you have seen RSA. If you go to your banking websites and all, you will see RSA algorithm. So why we use RSA more, why we don't use ECC much, what is symmetric cryptography? Like in my case, I have shown you AES. If you know about the BitLocker that you have on your Windows machine, it uses the same concept of symmetric key cryptography, wherein you just have a single key. With the help of single key, entire your hard drive gets encrypted if you basically turn it on. Okay, guys. So thank you for attending to the session. I hope you learned a lot today. Bye bye. Take care.